Okay, everybody. So what we have done now is you should have made your cotton ball launcher using the Science Buddy video on how to construct that launcher. Okay, so your launcher should look something like this. It might be slight variations based on your toilet paper holders or your pencils, but it should look something very similar to this. If you pull from the bottom here from the pencil, I'm putting my fingers here, you should be able to create sort of a plunger effect. It is the energy for this system, the energy that is going to launch our cotton ball into the world is coming from the tension created in our rubber bands. Okay, so attached to this project, I have included a Google slide. And on this Google slide, you're going to fill it out by completing the experiment. So I'm going to go ahead and share my screen with you so that you can see my example of it. Okay, so your Google slide, pull that, there we go, looks like this. Okay, so let's go ahead before we talk about the details of this and run through what the experiment is. Okay, what are we measuring in this experiment? What are we measuring? What do we want to know? Go ahead and say it out loud. No one's listening. So go ahead. What are we measuring in this experiment? Okay. What we want to know is how far will our cotton ball travel from our launcher? Okay. When we launch this cotton ball into the world, how far is it going to travel from our cotton ball launcher? Okay. How are we going to know if our experiment is fair and equitable each time we run a trial on it, right? So we want to make the experiment as fair and even as possible in order to get the best possible data from the experiment. So how do we do that? What is it that we need to control for in our experiment? You're thinking to yourself, okay? We need to control for as many of the variables in our experiment as we can. We want to limit anything unusual, anything different from one trial to the next. If you remember, a variable is a condition that can be changed in an experiment. So what we don't want to do is have our experiment look different each time we run the trial. We want to keep all of the factors, all of the conditions essentially the same. This is a controlled variable. So these are when we hold all the conditions constant or the same for each trial in our experiment. Every single trial should be equal in order for it to be fair. So I'm going to give you an example right now. One of the variables that we can control in our experiment is that we can use the same cotton ball every single time we do the experiment, because there is a chance that some cotton balls are bigger than others. Maybe some are more condensed than others. Maybe some are very fluffy. And this would affect how far the cotton ball could travel. I am going to give you about 10 seconds here. I want you to think about what are some of the other variables that we are going to need to control when we launch our cotton ball from our launcher. I'm going to give you 10 minutes, or 10 seconds. I want you to think about it in your head. You should be able to call out at least one more controlled variable. Okay, so I'm going to give a list of some of these. I want you to actually control for this when you do your test, okay? So the first one, we are going to try and use the same cotton ball every time. Your cotton ball is in the bag of your envelope. You should be able to use one of those cotton balls to do all 6 of your trials. I did give you multiple cotton balls. You can try launching more than one cotton ball at a time, but when you do your 6 trials, you should use the same number of cotton balls every single time, okay? The third one here is start your launch from the same location. So when you measure how far the cotton ball travels, you want to make sure that you're starting the launch from the exact same place each time so that you're accounting for the fact that it's not going to go that distance to the launch site. Okay. Fourth, you want to pull the plunger back the same amount each time. If you would like to make a mark on the plunger to make sure that you're pulling it back the same amount each time, you can do that. But one time you don't want to pull it back a little bit and the next time pull it back a whole bunch. You want to pull the plunger back the same distance every time. And lastly, you want to make sure that you're testing your cotton ball launcher in the same location for all 6 trials. You know, don't do one trial in your kitchen and then do one trial in your yard, because you can't control for maybe the breeze that's outside or some other condition that could impact how far the cotton ball would travel. So you want to make sure you're doing all 6 of your trials in the same location. Okay. Once you have come up with how you're going to do your test, I want you to go ahead and complete the experiment. And this involves filling out your Google slide. You are going to do, if you look on the left-hand side here, you're going to do 6 trials. You're going to measure how far the cotton ball traveled each time. You want to indicate the units. So you can use the meter stick that you made during your constellation project. You can use a yardstick. You can use a 12-inch ruler, whatever you have, a tape measure, whatever you have at home is fine. Okay. And then once you've done that, I want you to go ahead and answer the 4 questions on the Google slide. Okay. Please put your answers on the slide that I have provided for you. There is a slide for every student, and I can see it once you have filled it out. You need to push mark as done on your assignment so that I know that you have completed this assignment, because not everybody does it. So please, if you are not completing this optional assignment, do not mark your assignment as completed. All right, so go ahead. I'm going to unshare my screen now. Go ahead, get started testing your cotton ball launcher and have fun.